So here we have a GCSE exam question on box plots, and you can see they've given you a box plot, so some data to be extracted from that, and in part A you've got to construct a box plot or draw a box plot for the boys in this year 11 class, and for part B you've got to draw a box plot for the girls. So you've got to, if you like, separate the data between boys and girls, make two new box plots and do a little bit of comparison. Okay, let's have a look at how people did in the exam by looking at the examiner's remarks. So the examiners say that part A was the most successful question on the whole exam paper, so we shouldn't have any problem with the boys. But in contrast, few could interpret and draw a box plot correctly in part B for the girls, in other words, and there were a significant number of non-attempts at that question. The most common error was to plot the LQ, that's the lower quartile, at 70, or the boundary of the lower quartile, at 70. And the upper quartile was often plotted at 85. So this number was wrong, and from here that meant that the upper quartile was also wrong as well. So there was a problem. We'll have a look at why perhaps people made that mistake. And so actually they tell us here, so as given in part A. So all the people were doing was they were lifting the values from here and assuming it applied to the girls. Okay, so that makes sense. But let's have a go ourselves and see if we can avoid all errors and do part A, but also, most importantly, have a really good go at part B. Okay, so this box plot shows information about the marks of a whole year 11 class in a test. So I'm just going to write, this is the whole class. Okay, so in other words, what we're doing is splitting the class then in part A into boys and in part B into girls. But before we do that, let's just have a look at the information given to us on this box plot. Well, a box plot has no vertical axis here, so there's nothing that we can get from this axis here. So the height, for example, of this line, or the height of the box, all of that doesn't give us any statistical information. It's arbitrary, so we should ignore any heights because there's no y-axis or vertical axis, no scale on the left. Okay, so that's the first thing. We can only read our summary statistics from the x-axis or the horizontal scale. And what have we got then that we can read off from this graph? Well, here we've got the if you like, the lowest mark, and the lowest mark we generally call the minimum. So this point here is known as the minimum, and so the maximum that this box plot reaches, so the spread of the box plot is from maximum to minimum. The maximum mark was 100, so if it's out of 100%, then that was full marks. So this point here we call the maximum. Now between here and here, again we can read off from the horizontal scale, is the interquartile range. So here we've got the interquartile range, and it goes from the lower quartile to the upper quartile, and I'm just labelling everything on there so that it helps me to answer the questions as I work my way through it. Okay, so for part A, the table shows information about the marks of the boys in the class. Well, here's then the minimum, so that's the lowest mark that any boy got, and here's the maximum, so that's the highest mark that any boy got. So now when we draw our box plot, we need to just, in fact I'm going to use a green pen now for this, we're going to just mark on this maximum and minimum, but we can go in fact right across. So we've got the lower quartile, which is for the boys is at 70, exactly as it is for the whole class in fact. The median is here. Well, we'll not worry about that too much. It's more important to get the lower quartile and upper quartile, and then this box area which represents the interquartile range. So we'll have the lower quartile and the upper quartile, and then the maximum, the highest, and then we'll mark on the median just to complete the plot. So 65 is going to be here, so if we make a mark here. The lower quartile is 70, so here. The upper quartile is 85, so here. And the maximum is 95, so we make a mark here. Now let's join up the interquartile range to make the box. And finally, we can draw a line through from the minimum to the maximum to complete the plot. Now that's fine. You can see that this is exactly what we've got up here. That's complete. But because they give us the median, I guess they might want that plotted as well. So we're going to plot the median. So we go to 80 and draw a line down here. Okay. So that completes the box plot for the boys. The more tricky thing is to make sure we get a box plot also for the girls. Now here we're going to have to do a little bit of thinking. It says 1/4 of the girls in the class scored 75 or less. So first of all, we've got a bit of information. Let's just think about that to start with. So 1/4 of the girls in the class scored 75 or less. So if we think about the girls, let's just write girls here, then if 1/4 scored 75 or less, then that must be where we mark the lower quartile. So the LQ for the girls must equal 75. Okay, that's the lower quartile or the boundary. So in other words, 1/4 of the marks were below that, so it's the boundary between the first quartile and the second quartile, so we call that the LQ. So that's good. They've given us one bit of information. Then they say that the interquartile range for the girls is the same as the boys. So the interquartile range is the upper quartile subtract the lower quartile. In other words, it's the difference between the upper quartile and the lower quartile. We know the lower quartile is 75, but we don't know what the upper quartile is. So what are we going to do? Well, they say it's the same as for the boys. So let's go back to this plot here. Now the IQR for the boys, or let's say the upper quartile for the boys, is 85. The lower quartile for the boys is 70. So we've got the interquartile range, just to complete our summary statistics here, is 85 minus 70 equals 15. So the interquartile range is the same for the girls. So the upper quartile minus the lower quartile equals the interquartile range. So the upper quartile minus the lower quartile must equal 15. Okay, and we know what the lower quartile is. The lower quartile is 75, so the upper quartile minus 75 equals 15. So if I add 75 to both sides, I've now got that the upper quartile equals 15 plus 75 equals 90. Okay, so the upper quartile for the girls is 90, the lower quartile for the girls is 75. Let's just circle those. And I think what we'll do, now that we've got that information, is we'll plot that immediately on the graph, because that gives us the box for our box plot. So we've got 75, which means we draw a mark here. And we've got 90, which means we can draw our upper quartile there. And we can join these together to show very clearly that this is the upper quartile range. Now, what we're missing is the median and the maximum and the minimum and maximum. In other words, the whiskers, as they're sometimes called, of the box plot. The median isn't so important. Sometimes you'll see box plots without the median, and since they give us no information here about the median, it can't actually be derived from the information that we're given here. So although we've got the median for the boys, we wouldn't be able to get the median for the girls, although we do know it would be somewhere between 70 and 90, so somewhere along here maybe. Okay, so we can't get the median, but we can get the minimum and the maximum, just by a little bit of logic. If we go back to the boys, we can see that the minimum for the boys was 65, so the lowest mark a boy got was 65, and the highest a boy got was 95. Yet if we look at the whole class, somebody got a minimum of 60. So the lowest mark was 60 for the whole class, and that must have been a girl. If we look at the maximum mark, again, that can't have been a boy, so the maximum mark of 100 must have been a girl. So in fact, from here we can deduce the minimum and maximum for the girls. Okay, so the minimum must be 60 and the maximum must be 100. And now if we join this together, that completes our box plot and completes this question.